Hey guys, today I'm going to show you geometric distributions. So here's some prerequisite knowledge you're going to need to answer the next example. Previously, for a binomial distribution, you used bins to see if the distribution was a binomial. However, since we are now talking about a geometric distribution, we now use BIFs. BIF stands for binary, independent, first success, and some probability of success. Binary means two outcomes, either it is a success or it's a fail. Independent is either assumed if stated or not if not stated. First success would be stated in the problem and so would some probability of success. Now, when describing a geometric distribution, you should use the shape, center, and variability. Note that for the shape of a geometric distribution, we don't have to check for conditions since it is always right skewed. For the center and variability, you would use the equations below found in the first page of your formula sheet in the third column in the probability distribution box to describe the mean and the standard deviation. Now that you know that, let's move on to the example. In 2016, the bottle flip challenge, flipping a water bottle into the air and landing it right side up, took the internet by storm. Michael is really good at the bottle flipping. On any given bottle flip, he has a 35% probability of landing the bottle right side up. Assume that each bottle flip is independent. Let x equal the number of flips it takes until Michael lands a bottle flip. A. Describe the distribution of x. B. Find the probability that it takes Michael 4 flips until he lands the bottle right side up. C. Find the probability that Michael lands the bottle right side up within the first 4 flips. Before I answer the question, it is smart to first decipher what they're asking. Since they mentioned probability, it is either going to be a binomial or a geometric distribution. For a binomial distribution, we use bins. However, for a geometric distribution, like this one, we use BIFs. So to start off, we want to check if it is binary. In this case, binary would mean if there is a successful flip, it lands, or it's a failure, it doesn't land, so that passes. For independent, we are told to assume that each bottle flip is independent, so in this case we can just check that off too. However, I just wanted to know that independent in this case means if one trial is affected by that. I just want to note that independent in this case means that one trial is not affected by the previous trial. For first success, they tell us that it's until he lands it, which means as long as the probability is met, this distribution is geometric. For same probability of success, it is stated in the question, which is p equals 35%, but we are going to convert to a decimal to plug it into the equation seen next. Now that we have met the conditions, now it's time to answer part A. Since in part A we are asked to describe the distribution, it means we must use previous knowledge. We learned that to describe a distribution, we need to use shape, center, and variability. The shape for a geometric distribution is always right skewed, so we could put that down. As shown previously, these two equations show both the center and variability. The center is mean mu of x equals 1 over p, and the variability is standard sigma, standard deviation of x equals the square root of 1 minus p over p. To calculate the center, we must plug in the probability of success, which is 0.35, to get 2.86 as the answer. This tells us the expected number of flips before Michael gets his first successful flip. For the variability, we must also plug in the probability of success into the second equation, provided to get 2.30 for the variability. Part B is asking for the probability it takes Michael exactly 4 flips until he lands it for the first time. So, for this part, since it takes exactly 4 flips, this means the first 3 flips were missed. So, the probability of him missing the first 3 flips is 0.65. However, since it was 3 flips, we must put an exponent on the 0.65's, which would be 3. Since he landed the last flip, I would multiply by 0.35 to get 0.096. An easier way to do this problem, however, is to use the calculator. We would be using Geomet PDF since this is a geometric distribution, and PDF because it is until he lands the bottle flip. So, to access Geomet PDF, you would click Menu, Probability, Distributions, and Geomet PDF. For prob success, put in 0.35 since that is the probability of success for him landing it. For the X value, put 4 since it takes exactly 4 flips for him to land it for the first time. You should also end up with 0.096. Remember to write it out and to label each number to get full credit. Now, for part C, we're looking at the probability that he makes it in 1, 2, 3, or 4 flips. Since I'm looking at all of these probabilities, I'm going to add it all together. We already know that for one flip it is going to be 0.35, so we can already put that down. For 2 flips, it means he missed the first one and then made the second one, so we could put down 0.65 times 0.35. For 3 flips, it must have meant that he missed the first 2 flips, so then we put 6.65 and square it since he missed twice, and multiply by 0.35 since he made the last one. For 4 flips, we already know that from part A that this is going to be 0.096, so we can add it all together and we get 0.822. Now, an easier way to do this as well is to use the calculator. To find Geomet CDF, click on Menu, Probability, Distributions, and Geomet CDF. We are doing Geomet CDF since this is a geometric distribution, and CDF since the S is for the probability within the first 4 flips. For prob success, put 0.35 as you did last time, since this is the probability of success. For lower bound, put 1 since this is the minimum is 1 flip. For upper bound, put 4 since we are looking for within the first 4 flips. You should get the same answer as before, which is 0.82. Thank you.